now we're going to solve the system. This is question 2. X plus y minus z equals 6. 3x minus 2y plus z equals negative 5. And x plus 3y minus 2z equals 14. So first, let's construct the augmented matrix by writing down the coefficients on the variables and the result of the additions and subtractions. So minus 2, 1, and negative 5, and 1, 3, negative 2, and 14. So here's our augmented matrix. And our objective is to get a 0 here and a 0 here for the moment. That's our immediate objective. Row 1 will not change. Excuse me. Row 1 will not change, so I've got a 1, 1, negative 1, and a 6. And now to get a 0 in this position, we'll take row 2 and subtract 3 times row 1, and that'll replace row 2. So let's do that. Row 2 is 3, negative 2, 1, negative 5. And 3 times row 1, negative 3 times row 1. So that'll be negative 3, positive 3, and negative 18. There's row 1, multiplied every one of those values by negative 3. So when we add these up, we get a 0, a negative 5, a 4, and a negative 23. So 0, negative 5, 4, and negative 23. Now we need to get a 0 here. So we'll just take row 3, and from it we'll subtract row 1, and that will replace row 3. So let's write down row 3. 1, 3, negative 2, and 14, and then subtract row 1 from it. Negative 1, positive 1, negative 6. Add these up. There's our 0. We get a 2, a negative 1, and an 8. 0, 2, negative 1, and 8. Good, we have zeros in both of those positions. Now let's go on. And now we have to get a 0 in this position. So row 1 won't change. Row 2 will not change. And we've got to get a 0 in this position. We already have a 0 here. So what we'll do, we'll multiply row 2 times 2 to row 2, and we'll add that to 5 times row 3, and that will replace row 3. So 2 times row 2. So that's going to be negative 10, 8, negative 46, and 5 times row 3. So that'll be 10, negative 5, and 40. Now let's add these up. And there's our 0. Here's 3, and here is negative 6. So we have 0, 3, and negative 6. Now we need to get a 1 here and a positive value here. So we'll take row 1, never changes. minus 1 and 6. And we'll multiply negative row 2 will replace row 2. And so now we have a 0, a 5, a negative 4, and a 23. And we'll multiply row 3. Let's see. 1/3 row 3 will replace row 3. That means we have a 0, a 1, and a negative 2. So this implies that since this is a z position, z equals negative 2. So let's take row 2, and row 2 implies that we have 5y minus 4 times z, but z is negative 2. Negative 2 equals 23. So we have 5y plus 8 equals 23. So 5y, subtracting 8 from both sides, is 15. Dividing both sides by 5, we have y equals 3. So good, y equals 3. Now let's go to row 1, and we have 1 times x is x, plus 1 times y is y, but y is 3, minus 1 times z, but z is negative 2, and that equals 6. So we have x plus 3, and a minus times a minus is a plus 2 equals 6. So x plus 5 equals 6. So subtracting 5 from both sides, x equals 1. X equals 1. So our ordered triple is 1, 3, and negative 2. That's the solution, but we have to check it. So our ordered triple is 1, 3, negative 2. What you do is replace x, y, and z with the appropriate values 1, 3, and negative 2 respectively. In each of these equations, make sure you get the results stated for each equation. If you did that, we did it right. I checked it, and we did do it right.